Hello viewers, welcome to our channel Career Prep. In this video, we'll learn about the concept and formulae on the topic combinations. The study of permutation and combination is important for developing analytical and problem-solving skills and provides a foundation for advanced mathematical concepts in a variety of fields such as probability, statistics, and computer science. Permutation and combination forms an important portion in competitive exams like SSC, UPSC, railways, banking, etc. Since questions based on this topic are most frequently asked in competitive exams, it makes sense to understand the concept well. The concept, formulae, and questions on combinations are dealt with in this series of videos along with detailed explanations to make you understand the topic easily. Before we begin, please subscribe to our channel. Also press the bell icon to get notifications as soon as we post a new video. So let's start. Let's first understand the basic difference between permutations and combinations. Permutation. A permutation is an arrangement of some or all of a number of objects in a definite order. Now let's understand this definition with the help of an example. Let's suppose that there are three letters A, B and C. The permutations that can be made by taking the letters A, B and C two at a time are AB, BA, BC, CB, CA and AC. As you can see, there are 6 arrangements. Now each of these arrangements presents a different arrangement of the two letters. As you can see, AB is completely different from BA because in AB, A is in the first position, whereas in BA, B is in the first position. Similarly, BC is completely different from CB. Likewise, CA is completely different from AC. So, in permutation, the order of the two letters matters since different orders gives different arrangements. Now, these 6 arrangements are called permutations of 3 objects taken 2 at a time. So, permutation is arrangement and the order matters. Let's now understand what is combination. A combination is the selection of some or all of a number of objects where the order of selection does not matter. Now let's understand this definition with the help of an example. Let's suppose that there are 3 letters A, B and C. The selections that can be made by taking the letters A, B and C two at a time are AB, BC and CA. So there are 3 selections here. Now here the order of the two letters does not matter since a group only refers to the selection of two letters at a time. So whether it's AB or BA, BC or CB, CA or AC does not matter in the formation of groups. So AB and BA are the same since you are selecting the same two letters A and B. Similarly, BC and CB are the same because you are selecting the same two letters B and C. Likewise, CA and AC are the same since you are selecting the same two letters C and A. So, in a combination, the order of the two letters does not matter. So, combination is selection where the order of the objects does not matter. Hope you have understood the difference between permutations and combinations. Permutation is arrangement and the order of the objects matters. Combination is selection and the order of the objects does not matter. Now, in problems on permutations and combinations, whenever you are whenever you are asked to arrange some objects, then you should know that it is a permutation problem. And whenever you are asked to select some objects, then you should know that it is a combination problem. In this video, we'll learn in detail about combination. Here are a few formulae which will help you to solve problems on combinations. The number of combinations of n dissimilar things taken r at a time is given by NCR, and NCR is equal to n factorial divided by r factorial multiplied by n minus r factorial. Now let's understand this with the help of a few examples. The number of selections of 5 dissimilar things taken 3 at a time is given by 5C3. Now according to the formula, 5C3 is equal to 5 factorial divided by 3 factorial multiplied by 5 minus 3 factorial. This is nothing but 5 factorial divided by 3 factorial multiplied by 2 factorial. Now 5 factorial can be written as 5 multiplied by 4 multiplied by 3 factorial. The 3 factorial in the numerator and the 3 factorial in the denominator gets cancelled, and on solving this we get 10. So there are 10 selections that can be made out of 5 dissimilar things taken 3 at a time. Now the value of 5C3 can be found out using the shortcut method. Here, starting with 5 in the descending order, there has to be a multiplication of 3 numbers. So 5 multiplied by 4 multiplied by 3. This will be in the numerator. Now since there is the number 3 as the subscript here, it will be 3 factorial in the denominator here. So 5C3 is equal to 5 multiplied by 4 multiplied by 3 divided by 3 factorial. Now 3 factorial is nothing but 3 multiplied by 2. So on solving this, we get 5C3 is equal to 10. So 10 selections can be made out of 5 dissimilar things taken 3 at a time. Look at another example. In how many ways can a committee of 3 be made out of 7 students? So there are a total of 7 students and a committee consisting of 3 students is to be formed. So this means that 3 students have to be taken at a time. Obviously, no student is repeated in a particular committee. The number of um, such committees that can be formed by taking 3 students at a time out of 7 students is given by 7C3. Now according to the formula, 7C3 is equal to 7 factorial divided by 3 factorial multiplied by 7 minus 3 factorial. This is nothing but 7 factorial divided by 3 factorial multiplied by 4 factorial. Now 3 factorial is 6 and 7 factorial can be written as 7 multiplied by 6 multiplied by 5 multiplied by 4 factorial. The 4 factorial in the numerator and the 4 factorial in the denominator gets cancelled. The 6 in the numerator and this 6 in the denominator gets cancelled, and we get the final answer as 35. So 35, there are 35 ways that a committee of 3 can be made out of 7 students. Now the value of 7C3 can be found out using the shortcut method. So in the numerator, starting from 7, in the descending order, there has to be a multiplication of 3 numbers. So in the numerator, it is 7 multiplied by 6 multiplied by 5. In the denominator, since there is the number 3 here as the subscript, it is 3 factorial in the denominator. So 7c3 is equal to 7 multiplied by 6 multiplied by 5 divided by 3 factorial. Now 3 factorial is 6. So the 6 in the numerator and 6 in the denominator gets cancelled and we get the answer as 35. Let's now look at one more formula. The number of combinations of n dissimilar things taken all at a time is NCN. Here R is equal to N. So according to the formula, NCN is equal to n factorial divided by n factorial multiplied by n minus n factorial. N minus n factorial is 0 factorial. So now we have n factorial divided by n factorial multiplied by 0 factorial. The n factorial in the numerator and n factorial in the denominator gets cancelled out. We know that 0 factorial is 1. So the final answer is 1. Now let's use this formula in an example. The number of selections of 3 dissimilar things taken all at a time is given by 3C3. Now according to the formula, 3C3 is equal to 3 factorial divided by 3 factorial multiplied by 3 minus 3 factorial. 3 minus 3 factorial is 0 factorial. So now we have 3 factorial divided by 3 factorial multiplied by 0 factorial. The 3 factorial in the numerator and 3 factorial in the denominator gets cancelled out. 0 factorial is 1. So we get the final answer as 1. Also note that NC0 is also equal to 1. Here R is 0. Now according to the formula, NC0 is equal to n factorial divided by 0 factorial multiplied by n minus 0 factorial. N minus 0 factorial is nothing but n factorial. So now we have n factorial and 0 factorial is 1. So now we have n factorial divided by 1 multiplied by n factorial. The n factorial in the numerator and the n factorial in the denominator get cancelled out and finally we are left with the answer as 1. So NC0 is equal to 1. Also note that NCR is equal to NC n minus R. This equation is especially useful when the values of n and r are very high. For example, 16C13. Clearly this is very cumbersome to solve. So we'll use this equation here. So 16C13 is equal to 16C 16 minus 13. This is nothing but 16C3. Now this is quite easy to solve. Now 16C3 is nothing but 6. Starting with 16 in the descending order, there has to be multiplication of 3 numbers. So in the numerator, it is 16 multiplied by 15 multiplied by 14. And in the denominator, it is 3 factorial because there is 3 as the subscript here. Now 3 factorial is 6. So on solving this, we get the answer as 560. Let's now look at the differences between permutation and combination. Arrangement is permutation. Selection is combination. Order matters in permutation. Order does not matter in combination. Permutation formula is NPR is equal to n factorial divided by n minus r factorial. Combination formula is NCR is equal to n factorial divided by r factorial multiplied by n minus r factorial. NPN is equal to n factorial. whereas NCN is equal to 1. The shortcut method to find the value of 5p3 is starting from 5 in the descending order. There has to be a multiplication of 3 numbers. So 5p3 is equal to 5 multiplied by 4 multiplied by 3. The shortcut method to find the value of 5c3 is starting from 5 in the descending order. There has to be a multiplication of 3 numbers, and this has to be in the numerator. So 5 multiplied by 4 multiplied by 3 is in the numerator, and in the denominator it is 3 factorial because 3 is the subscript here. Make a special note of point number 3, point number 4 and point number 5 so that you are not confused while solving problems on permutations and combinations. Viewers, please go through this video till you have understood the concept. Please do watch all our videos on solved problems on combinations for better understanding. Please do watch our video on solved problems on combinations part 1. If you have liked this video, please like, subscribe and share this video. Thank you.